So, for the last couple of years, it feels like the entire business world has been obsessively watching a sports team practice.
Oh, absolutely. Just completely fixated on the warm-ups.
Right. We've all been sitting in the bleachers, analyzing their routines,
Yeah.
marveling at how much money they spend on this massive training facility, aggressively debating coaching strategies.
And ignoring the actual season.
Exactly. For all that attention, we really haven't been talking about what happens during the actual championship game. We've been completely 100% fixated on AI training.
Yeah, the preparation phase.
Right. But today, we want to welcome you, the listener, our fellow learner, to this deep dive. Because our goal today is to cut through all that jargon, be an antidote to the AI information overload, and look at the actual championship game.
Which is inference.
Yes, Inference. We're grounding today's deep dive in a really practical recent article by AI thought leader and author Johan Steyn. It's called "The AI Term Business Leaders Can No Longer Ignore."
It's a great piece. Really zeroes in on the reality of the situation.
It does. We are going to completely demystify this highly technical sounding word, inference, and we'll reveal why it's actually the ultimate battleground for business survival, cost management, and, well, customer experience.
Because the narrative has quietly shifted, hasn't it?
It really has.
Like the fixation on the preparation phase totally makes sense because the numbers are just staggering. We've been captivated by the billions of dollars spent simply teaching these frontier models how to exist.
The billions spent on building the training facilities.
Right. But Stan's article strips away that Silicon Valley hype. It forces us to look at the operational reality. We are moving out of the laboratory phase, finally, and that means the focus has to shift to applying the AI, which is all about inference.
Okay, so before we get to the massive business impact and why this is suddenly a boardroom crisis, we have to, lock down the actual mechanics of what is happening under the hood.
Let's do it.
So the two concepts we're weighing here are training versus inference. Now, let's say training is the equivalent of sending someone to an incredibly expensive, decade-long medical school.
I like that.
Right. You're pouring money, time, massive oceans of data into their brains so they learn to recognize patterns.
Yeah, foundational knowledge.
Exactly. So if that's training, then inference must be the actual daily clinic hours. It's that doctor sitting in the office diagnosing a new patient every single day.
That is a perfect way to frame it. And to build on that medical analogy, Steyn points out something crucial. The vast majority of companies out there are never going to build or fund their own medical school.
Because it's just too expensive.
Oh, way too expensive.
Pat?
The cost barrier to entry to train a massive frontier AI model from scratch is simply too high for a standard enterprise.
Right, you're talking billions.
Exactly. So instead, their entire relationship with artificial intelligence is going to be based on paying the doctor's hourly rate. They're going to be paying for inference.
Paying for the diagnosis.
Yes. Inference is that exact moment when a fully trained model is used to do something in the real world. It takes a new, unseen prompt like an email, a data set, a customer question, and it generates an answer.
So it's the execution phase. But wait, I want to dig into the actual mechanism of that generation for a second, because honestly, the word inference sounds like a really benign IT term.
It does sound pretty harmless.
It sounds like, clicking a drop-down menu on a dashboard. If inference is just the AI doing its job, why has this suddenly become a critical boardroom issue rather than just a footnote for the tech team?
Well, we have to contrast it with how we're used to software working. Think about a standard Google search.
Okay.
When you search for something, you're essentially asking a system to retrieve an existing document from a massive, well-organized filing cabinet.
It's just finding a match.
Right. It's a retrieval process. It's incredibly cheap and highly optimized. But inference is not retrieval. When you ask an AI to, say, summarize a meeting or write an email, it's not pulling a pre-written document from a server somewhere. It is calculating the probabilistic sequence of every single word or token it generates in real time.
Wait, so it's doing math for every single word?
Every single word. It has to push your prompt through billions of neural pathways, which we call parameters, to mathematically determine the next best word. And then the next, and the next.
Wow. So it's active computation happening from scratch every single time you hit enter?
Every single time. And that active computation requires raw processing power. mean, it requires electricity, it requires physical server space in a data center.
So it's not just software magic, there's a physical toll.
Exactly. When a company trains a model, it's a massive upfront capital expenditure. It hurts the balance sheet, sure, but it's a known capped quantity. You train it, you're done.
The medical school tuition is paid.
Right. But inference is entirely different. Every time an employee asks the AI to format a spreadsheet, or a customer asks a chatbot for their balance, that specific action triggers a marginal cost.
It's a meter that never stops running.
A meter that never stops running. Exactly.
Okay, so if the math required to generate these answers is that intense, it fundamentally changes how we have to look at the underlying hardware. We can't just look at the software layer anymore. We have to follow the silicon.
Following the money right to the hardware.
Right, because Steyn cites this fascinating Reuters report from early 2026. It highlights how NVIDIA, obviously the absolute giant in the AI chip world, is pushing aggressively into the inference market.
Yeah, that was a huge signal.
They are framing real-time AI usage as their major growth engine now, not just selling the chips used to train the models, but chips to run them.
And the Financial Times actually backed up that observation recently.
Mm-hmm.
They noted that this pivot by NVIDIA reflects a much broader market belief.
Which is what, exactly?
The consensus is that inference could soon account for the vast majority of all future AI infrastructure demand.
The majority. Wow.
Yeah, think about it. You only train a specific model once, or maybe twice a year. But you might run inference on that exact same model 1 billion times a month across your global user base.
That makes sense. The volume is just entirely lopsided.
And the hardware architecture required for that is fundamentally different. Training requires massive parallel processing to analyze oceans of data over months.
Like studying for a massive exam.
Right. But inference requires extremely fast, low-latency sequential processing. It has to spit out answers in milliseconds while handling thousands of simultaneous user requests.
Okay, wait, I have to play devil's advocate for you listening at home, because this sounds like a problem that Silicon Valley always solves.
Oh, I know where you're going with this.
Right. Like cloud providers, AWS, Microsoft, they spent the last 20 years driving down the cost of computing and storage. We used to worry about server costs, and now we basically treat cloud storage as infinite and practically free.
It feels free, yeah.
So why should a VP of sales or an operations director panic about inference costs today? Won't the tech companies just optimize it and make it, pennies on the dollar by next year? Why should a non-tech leader care about hardware demand?
It's a fair question, but the assumption that AI compute will follow the exact same cost-down trajectory as traditional cloud storage ignores the physical constraints of the technology.
How so?
Well, storage gets cheaper because we figure out how to pack more static data onto smaller and smaller drives. But as we just discussed, inference is not static. It's active, probabilistic math occurring across billions of parameters.
The active computation again.
Right. We are actually running into hard physical limitations regarding power grid capacity and the sheer heat generated by these chips.
So you can't just shrink it and make it cheaper instantly.
No. While costs will optimize over time, the volume of queries is scaling exponentially faster than the hardware is becoming cheaper. But more importantly, and this is Steyn's real point for business leaders, this massive demand for inference chips is the ultimate leading indicator of human behavior.
So if companies are buying billions of dollars of hardware specifically dedicated to running daily AI queries, it proves those queries are actually happening.
Exactly. It's a signal that AI is becoming an operational reality. It's not just a capital markets headline designed to boost a stock price anymore.
It's the chatbot actually talking to your customers right now. It's the agent reviewing your supplier invoices.
Yes. Businesses are finally attempting to deploy this technology at a massive scale.
Oh.
But here's the catch that is the exact point where the polished, magical facade of artificial intelligence often crumbles.
The transition from testing an AI to relying on an AI is completely unforgiving, isn't it?
Oh, it is brutal.
Steyn brings in insights from Deloitte on this, pointing out that rising inference costs, latency pressures, and infrastructure constraints are forcing organizations to completely rethink where and how their AI workloads run. We are seeing a huge reality check between the pilot phase and scale.
The pilot trap.
Yeah, the pilot track. Running an AI pilot is like running a boutique bakery.
I love this analogy.
It's very easy to bake 10 perfect artisanal cupcakes for a small test audience of executives, right? You control the oven, you control the ingredients, you hand deliver them, they look amazing.
And everyone is thrilled.
Right. But running inference at scale means you are suddenly told to bake 10,000 of those exact same cupcakes every single day, distribute them globally, and keep them perfectly fresh.
Which is a whole different ballgame.
Scaling up instantly exposes every single flaw in your supply chain.
Absolutely. Because when 10 executives are testing a pilot project in a closed environment, a slow response time doesn't really matter. But latency, meaning the literal lag time between a customer hitting enter and the AI starting to type its answer, that becomes a massive issue at scale.
Because every delay hurts user adoption.
Exactly. If your boutique AI model takes 3 or 4 seconds to do the matrix multiplication required to generate a response, your test users might forgive it. They're just testing it.
Right, they know it's a beta test.
But put that in front of a frustrated customer who is trying to resolve a billing error on your website. A 4-second delay feels like an absolute eternity.
They'll just close the window.
Exactly. Every millisecond of latency destroys adoption.
And it's not just about the speed, right? It's about the quality of the ingredients you are feeding into that automated bakery. Steyn warns that we cannot confuse the polished output of a pilot with actual business value. He says inference is the moment where the AI model meets the messiness of real workflows.
And that messiness is the single biggest hurdle to scale. Inference is the exact point where all of your organization's secrets come out.
The skeletons in the data closet.
Precisely. Weak internal data, poor data governance, fragmented systems, they are painfully exposed to the light of day. Look at it this way. A large language model does not know the difference between a current company policy and an outdated PDF from 2019 that someone accidentally left on a shared server.
Oh, wow. Yeah, it just reads everything.
It just probabilistically generates the most confident-sounding answer based on whatever data it has access to.
Let's ground that in a real-world scenario for the listener, because the corporate risk here is massive.
It really is.
If you scale up an AI customer service agent without cleaning your internal data first, that model might pull from an obsolete training manual, and then it confidently promises a customer a 100% refund policy that no longer exists.
Right. And because it is an automated agent acting on behalf of the company, that hallucinated answer just created a binding financial liability.
Which is terrifying for a business.
Completely. The model did exactly what it was mathematically designed to do, but the messy internal workflow turned it into a crisis. And this is why the broader industry data is showing such a sharp pivot right now.
What kind of pivot?
Well, Steyn references observations from Information Week, noting that business leaders in 2026 are aggressively shifting their mindset. The era of trying to put AI everywhere is over. Leaders care way less about that now.
So what do they care about?
They are focused on using AI to solve strictly defined, narrow problems that have measurable impact.
That makes a lot of sense. And actually, McKinsey's Global AI Survey echoes that exact sentiment. They found that while organizations are widening their initial use of AI, a massive number of them are deeply struggling to convert that early experimentation into scaled value.
They are stuck in that pilot trap.
Right. Because applying a massive generalized AI model to every single daily task is just too computationally expensive and way too risky.
Which brings us to the operational solution. Because once you understand the economics of inference, you realize you don't always need to hire the brain surgeon to sort your mail.
Right. I don't need a supercomputer for everything.
Exactly. To escape the pilot trap, companies are realizing they need to match the size of the model to the complexity of the task. If you just need an AI to route incoming customer emails to the correct department, you do not need to run inference on a massive trillion-parameter frontier model.
That would cost a fortune.
It would. You can use a small, highly specialized language model that costs a fraction of a cent per query and operates with practically zero latency.
You are matching the compute cost to the value of the problem, which honestly requires a fundamental rewrite of the leadership playbook.
It totally does.
If you are listening to this right now and dealing with stalled pilots or out-of-control cloud bills, you have to change the questions you're asking your teams. You don't need to be a chip expert, but you absolutely must internalize that inference is where AI lives or dies commercially.
It impacts your cost base, your productivity gains, and your governance exposure.
Exactly. The old playbook was entirely focused on ambition, right? The questions were, do we have an AI strategy? Or can the model write this email?
Can it summarize this massive document?
Right. But the new playbook is entirely focused on operational scale. The new question is, what happens when this specific tool is used 10,000 times a day?
And more importantly, can we afford to run it, trust it, and govern it at scale?
Right, without a human checking every single response. This shift completely moves artificial intelligence out of the exclusive realm of the tech team or the IT department.
It absolutely does.
It drops it squarely onto the desks of operations, legal, and finance. It's no longer about the magic of the trick. It's entirely about the cost of the ticket.
That is so true. And Johan Steyn calls out this exact transition by highlighting the concept of AI theater.
AI theater.
Yeah. For the last few years, we have been living in a world of flashy demos, massive parameter counts, and theoretical capabilities. It's all theater.
The boutique cupcakes.
Exactly. But the future of AI in business won't be decided by the tech giants who train the biggest, most expensive models. The future is going to be shaped by the companies that avoid AI theater entirely.
The ones doing the actual work.
Right. The winners will be the organizations that figure out how to clean their data, match the right size model to the right problem, and actually use AI repeatedly, responsibly, and at scale. They will be the ones who master the economics of inference.
We have truly moved from the abstract hype of the laboratory straight into cold, hard economic reality.
We really have.
If there is one thing to take away from this deep dive into Steyn's research, it's that inference is simply the language of practical AI value. It's the intersection where a company's technological ambition finally crashes into its operating cost.
And as a listener, you now have a distinct strategic advantage.
How so?
Well, the next time you're in a meeting or you have a software vendor sitting across the table boasting about some magical new AI feature they want to sell you, how to look past the polished demo.
You can ask the real questions.
Exactly. You can raise your hand and ask the only question that actually matters. What is your inference strategy?
I love that.
Ask them, are we using a massive model for a simple task? And exactly how much compute cost are we incurring every single time an employee clicks that generate button?
It is the ultimate reality check. It forces everyone in the room to stop talking about the practice session and focus entirely on the championship game.
Absolutely.
Now, as we wrap up, I want to leave you with a final, completely new thought to mull over on your own. And it builds entirely on the economic reality of inference costs that we've been unpacking today.
Well, this is a good one.
For the last 20 years, we have been living in a digital world where software interactions felt practically free. You do a web search, you send an email, you open a cloud document. It doesn't cost you a measurable dime in that exact moment.
The infrastructure costs are totally hidden from the user.
Right. But if every single AI prompt carries a literal, measurable compute cost during inference, if it requires active matrix multiplication and raw electricity to generate every single word, how long until the era of free software tools ends? Will we soon enter a corporate world where employees aren't just given travel budgets or office supply budgets, but strict monitored inference budgets?
That is a wild thought.
Are we heading toward a future of prompt quotas just to prevent a well-meaning team from accidentally bankrupting their company's cloud infrastructure by asking the AI too many questions?
I mean, the invisible costs of computation are rapidly becoming visible, and it's going to fundamentally change the way organizations distribute tools to their workforce.
It is going to rewrite the financial structure of daily work entirely. Well, thank you for joining us on this deep dive. We hope you walk away today not just with an understanding of a new technical term, but with a completely new lens for viewing the future of business technology and the real cost of artificial intelligence.
Thanks for tuning in.
Stay curious, keep asking the hard questions, and we will catch you on the next one.